The findings from this study raise significant concerns about the potential metabolic consequences of dietary protein restriction in healthy, lean men. The research highlights a striking increase in energy requirements to maintain body weight, which may present challenges for individuals seeking to regulate their dietary intake. The necessity to consume additional calories simply to avoid unintended weight loss could lead to unforeseen metabolic imbalances, particularly for those unaware of the body's compensatory mechanisms. A major point of concern is the role of fibroblast growth factor 21, FGF21, a hormone that increased dramatically in response to protein restriction. While FGF21 has been linked to metabolic regulation and adaptation to dietary stress, its prolonged elevation and its potential long-term effects remain poorly understood. The results suggest that FGF21 may drive an increase in energy expenditure, but the underlying mechanisms are not fully elucidated. The reliance on animal models to support these findings introduces further uncertainty, as the metabolic responses in mice may not always translate directly to human physiology. The study's observation that FGF21 knockout mice did not exhibit the same metabolic adaptations raises additional questions about the broader implications of FGF21 elevation in humans. Another concerning aspect is the metabolic trade-off associated with protein restriction. While previous research has suggested that reducing protein intake could enhance insulin sensitivity, the study does not provide definitive evidence that these effects are beneficial in the long term. The increase in glucose infusion rate observed in the hyperinsulinemic euglycemic clamp test indicates improved whole-body insulin sensitivity after protein restriction, but whether this adaptation is sustainable or advantageous over time is uncertain. The absence of changes in resting metabolic rate, physical activity, or substrate oxidation suggests that the observed metabolic shifts are largely meal-dependent, adding complexity to the interpretation of the findings. Furthermore, the study raises practical concerns about dietary adherence and sustainability. The increase in energy intake required to maintain weight on a protein-restricted diet, regardless of whether protein was replaced with carbohydrates or fats, suggests that such a diet may not be easily manageable for individuals with strict dietary goals. The transition back to a habitual higher protein intake resulted in a corresponding decrease in energy needs, but the long-term effects of these fluctuations on metabolic health remain unknown. Ultimately, while the research sheds light on the significant metabolic consequences of dietary protein restriction, it also underscores the potential risks of altering macronutrient intake without a clear understanding of the broader physiological implications. The findings suggest that protein restriction is not a simple dietary strategy, but rather a complex intervention that demands careful consideration. Future research will be essential to determine whether the observed metabolic changes lead to positive or negative health outcomes in the long run.